charged to liquid. It's going to go in as R22 and come out as R22. Your refrigerant blends are what they call azeotropic refrigerants. They're multiple types of refrigerant blended together to make a refrigerant. And I know we went over all this in the last class that I taught, but refrigerant blends will leak at different rates. If you have a leak in the system, if it's an R410 system, I think 410 is put together with, I think, 3 different types of refrigerants, and it's a percentage of all 3 different types. When it leaks out, it doesn't know to leak out 25% of this one and 10% of this one and 35% of this one. It just leaks out whatever it can at that point. So when you lose a few pounds of refrigerant, you no longer have a 410 refrigerant. I really don't know what it is. It's a different blend. So on azeotropic or blended refrigerants, you have to charge them as a liquid type refrigerant. And I've got a little thing in here. It's called a quick charge. I told y'all and I just seen this one, but I told y'all in the last class, when I charge with blends, I'll turn my tank upside down and you just crack the gauge open a little bit and you let the manifold become your metering device. Inside the manifold, the pressures will drop off and it'll turn to a vapor. They make a little tool, put it right on the can, flip it upside down, and it meters in that little tool, flashes it to a vapor, and lets it go into the system. So that way you're still coming out of the can as a liquid. And once it comes out of that can, doesn't matter at that point what it does, whether it goes to a vapor or stays a liquid, you're dumping all of it into the system anyway. So that's how you got to charge those. You've got, of your different blends, you have azeotropic blends, which is a blend or 2 or more refrigerants, but it has 1 boiling point. There is really no fractionation. It doesn't matter what the temperature is. The pressure is going to be the same. It's going to boil at the same rate. But you have near azeotropic. They act like azeotropic blends, but there's a temperature glide to them. So as the temperature drops down, the boiling point changes. As you start taking refrigerant out of that can, the boiling point of the refrigerant will change. The same way inside a system. As you start putting colder air across that evaporator coil, the boiling point of the refrigerant will change. It's like with R22, doesn't matter if you put 50-degree air across it or if you put 90-degree air across it. The boiling point of R22 is minus 41 degrees. It's going to be there constantly. With near azeotropic, it's going to fluctuate up and down, so they call that a glide. And zerotropic blends, they have a wider glide and they fractionate. So they're even harder to work with when it comes to charging systems up and trying to read your pressures. You got to know, really pinpoint what your temperatures are, your entering air, your leaving air, your condenser air, and what your pressures are, and try to pinpoint what it really should be. And near azeotropics, you probably won't deal with them. They're more in the line with commercial chillers when you're dealing with I think it's 407. They use that in commercial chillers, and some of the other refrigerants that you won't use a whole lot of. You'll use 410, 123, R22 still for probably another 8 years. About 8 years, 22 will be phased out, so you'll be done with that one, and then it'll be 410 and 123. But when we get further on down here, fractionation is just defined as when one or more refrigerants of the same blend will leak at a faster rate than the other. That's what fractionation is. And your temperature glide is range of condensing or evaporator temperatures for one pressure. So
Can you say the last part again?
for temperature glide,
Yeah.
it's range of condensing or evaporating temperatures for one pressure. So we've studied before on this chart up here. We know that at X amount of pressure, whatever refrigerant is going to be that temperature. With a temperature glide, it's not going to be consistent. There's going to be a glide in there, and a lot of that is dependent on other factors that are changing that refrigerant. We talked earlier about you could walk up to I could walk up to any can, recovery refrigerant can, and shoot a thermometer on it and put a gauge on it and tell you what type of refrigerant's in that can, whether it was marked or not. Just because you can take your chart and you can see if I walked up to a can and I seen that it was 80 degrees and where are we at here? If it was 80 degrees and the pressure was 100 or 235 pounds, I would know it was 410 refrigerant. You know, so we've talked about that. Whenever we get into recovering refrigerant, you can't blend refrigerants together. You have specific cans. One can for 410, one can for 12, which is not anymore, but one can for 22, one can for 134A. When you take those cans back in after you recover them, you take them back into the warehouse to turn them in, they're going to take a temperature and a pressure reading, and it better be close in the chart to what it says it should be, or they won't take it back. They'll say it's a mixture of refrigerants and they won't take it. They're really, really picky on that. So you've got to keep your refrigerants separated. For the CFC test, the core part of the test is just general knowledge of the history and refrigerant facts. It's general knowledge of the refrigeration industry. You're going to have to know the refrigerant cycle. We went over that. Compressor, condenser, metering device, evaporator, back to the condenser. So you got to know the cycle of the refrigerant. You got to know that we're at in a specific point of that system, whether it's a liquid, whether it's a vapor, whether it's a hot gas, whether it's a saturated vapor. At different points of that system, you got to know what the state of that refrigerant is, because some of the different types of recovering is where you can actually use the compressor itself in the equipment to recover the refrigerant out, or you can use an external machine to draw the refrigerant out. But you got to know where to put your taps on. So you got to know what part of the system to put a tap in there to get that refrigerant out of there. You don't want to put a tap where there's going to be liquid refrigerant. Your machine's not designed to draw out liquid refrigerant. You want to draw vapor out. So that kind of stuff. There's just general knowledge of the refrigeration industry. Your Type 1 certification is for small appliances, 5 pounds and under of refrigerant. Typically they are factory charged, sealed. You can't put a hose on them. Normally there is no connections to put your gauges on. They'll give you a little process tube that you put a tap valve on there and check it. They are mainly window air conditioning units, refrigerators, freezers, what they call a PTAC unit, which is just a thermal packaged air conditioning unit, kind of what you see in a hotel. The ones that are through the wall, that's a PTAC unit. That's your Type 1 certification. Type 2 certification is high pressure appliances. using a refrigerant with a boiling point between minus 58 and plus 50. That's an R22. R22 system is a high pressure system because R22, the boiling point is minus 41 degrees. So it's in that range. Then you have high pressure appliances, which uses refrigerant with a boiling point below minus 58. That's R410 now. 410, same piece of equipment. You can look at an R22 air conditioner and you can look at an R410 air conditioner. You can't tell, they look identical. But the 410 has a boiling point of minus 61 degrees. So that makes it a high pressure refrigerant. They're both classified under type 2 certifications. So you can do high pressure and very high pressure. Type 3 certification is a low pressure, like a low pressure chiller. All that stuff there uses refrigerant. The boiling point of that refrigerant is above 50 degrees. That's like R11, which is hardly ever used anymore, but it's still out there. That's a low pressure chiller. Some of these train Centrivacs, they're low pressure chillers. The suction side of that chiller runs in a vacuum. Anymore, nothing runs in a vacuum. Used to be R12, you could run R12 in a vacuum on a freezer, and it was fine. It made really cold air in a vacuum. But anymore, everything now runs with some sort of pressure on the suction side. If you get a Type 1 certification, just because you get a Type 1 certification, legally, you can't work on low pressure appliances. That's why they have a Type 1, a Type 2, a Type 3, or universal. You get universal, you can work on any of them. But if you get and it's really kind of odd, really strange, if you get a Type 3 certification, you could work on a piece of equipment that would have 300 pounds of refrigerant in it. But if you didn't get Type 1, you couldn't work on a little window air conditioning unit that's got 2 pounds. Legally, you can't do it. Doesn't make sense, but they want you to be able to understand the difference between a small appliance, a high pressure, a very high pressure, and a low pressure equipment, and they want you to know all 4 of them. So best thing to do is get universal, and you're good. I've had my card for 15 years. Never had anybody ask me to see it. Never had an inspector want to see it. The only person that's wanted to see it are the supply houses when I want to go buy refrigerant. They want me to show it to them so they can put the number down. It's very rare that anybody's going to ask you, but that one odd chance that you're out there recovering a piece of equipment and somebody walks up and wants to know if you're certified to use that recovery machine, you better have the card. You do have to keep very accurate records. My guys, I stress with them, whatever you recover, weigh it, write it down. They have a book. And whatever day they're doing, if they're recovering refrigerant, we know exactly how much they recover, because we recover so much refrigerant that we do get audited by the EPA. They want to know how much refrigerant we're handling throughout the year. So we've got to show them how much we've recovered, and we got to show them how much we've taken back to recycling facilities. The records that we did turn it in, we didn't just recover it and go out in the shop and open the valves and let it go. Some companies do that, you know. So keep accurate records on them. It'll cover you. Biggest thing on the core part is, again, we don't have to remember dates. You don't have to remember, like it used to be, you couldn't vent CFC and HCFC since July 1st, 1992. You used to have to remember that. Now you just got to know you can't vent CFCs HCFCs, HFCs. HFCs have no chlorine in them. They're not harmful, so they say. To the atmosphere, they don't really know, but they say they're fine. But you still can't vent them. You still got to recover them. The only thing we can legally vent to the atmosphere is nitrogen, that we're using that testing. You are allowed to put a small amount of refrigerant, R22, because it's an HCFC. It's got a little bit of chlorine in it. You can put a small amount of refrigerant into a system and fill it up with nitrogen to leak test. And once you do that, you can vent that to the atmosphere because you can't recover the nitrogen. And then no one wants it. So they will let you vent that to the atmosphere. They allow what they call de minimis venting, which is basically when you unhook your hoses, there's going to be a small amount of refrigerant in there. You can vent that to the atmosphere. You don't have to recover down to the very last bit. They are requiring now, though, low loss fittings on your recovery hoses. Used to be when you took them off, it would blow a decent amount of refrigerant out. Now the low loss fitting stores that refrigerant in the hose. So when you unhook it, you hear a little pop, and that's about all it is. It's very little amount of refrigerant. That's becoming a requirement, and pretty much any new hose you get, I think, has it built right onto it. I don't think they sell too many of the straight hoses anymore.
That little bit of gas is significant.
It used, yeah. I mean, they weren't really cracking. They didn't really crack down on you. They didn't want you doing it, even though it's only a couple ounces. If you look at it over, how many millions of people were out there working on this equipment every day, open up a couple ounces. It becomes, thousands of pounds a day.
I had no idea. Okay.
Yep.
But even the quick ones are even better on your fingertips anyway.
Yeah. Yeah, y'all should remember that from the last class. That boy's not in here, is he? I don't think. I taught a heating and air conditioning class last semester, and had a low loss hose, or had a low loss fitting on the hose. And I told one of our guys to take the hose off, and he unscrewed the line off the fitting, left the fitting hooked up to the equipment. When he unscrewed it, it just blew liquid refrigerant out, burned his fingers. You got to really be careful with that stuff. It only takes a couple seconds to get on your finger, because if it was 410, it's minus 61 degrees. At minus 61, just a couple seconds gives you frostbite. And I think his fingers were burnt for a couple weeks. He said that he could feel it. It kind of hurt. So the low loss fittings are better. You don't get that spray back all over. You don't get the oil back out of the system. Used to be when you take them off the high side, you would blow oil everywhere. It's just a mess. These things are a lot cleaner. One of the things that's on, I guarantee you will be on the test, on Clean Air Act is, or on the core, is the 3 R's: recover, recycle, and reclaim. Got to know the difference. It's all going out and recovering recovering refrigerant. But when you recover something, you remove the refrigerant in any condition from a system, and you store it in an external container. You're just recovering it. When you recycle it, you pull it out, you run it through a filter, and you put it back into the system. So you're recycling it back into it. You can, if you have a homeowner that has multiple pieces, you can pull it out of one system, filter it, put it into another system that he owns, and you're fine. But you can't pull it out of his system, run it through a filter, and take it down the road and sell it to Joe as new refrigerant. You can't do that. The homeowner can move it all around on his own property with his equipment. If he has multiple townhouses he can take it from one townhouse and put it in the air conditioner in another townhouse, but you can't sell it to somebody else. And then to reclaim is where you pull it out and you take it back to a manufacturer. They clean it up to manufacturer specs. I think it's ARI 700 standards. Then they can resell it as new refrigerant. So you got to know the difference between recover, recycle, reclaim, because they'll ask you on this test, what is recovering refrigerant and what is reclaiming refrigerant, and what's recycling it. Most people just put down removing it from the system, which is wrong. Just going to try to touch on some of the highlights here, and then we'll get more in depth in this next week. Again, the sales restriction, we don't need to know the date of when you had to be certified to buy refrigerant. You do need to know that there are no drop-in refrigerants for different refrigerants out there. There is no drop-in refrigerant for R22. They stopped making refrigerant 22 last year at some point. I forget when they stopped making it, but they don't make anymore. The only thing they're selling now is whatever they had stockpiled or whatever is brought back in and recycled or reclaimed and cleaned up and sent back out as new. When that's all gone, there is no more R22. And as of right now, they don't make a drop-in replacement. They have stuff out there called MP99 that's supposed to be a drop-in replacement for R22, and they found out it's flammable. And it explodes. So if it's an R22 system, put R22 back in it. They did the same thing when they banned R12. They had this stuff called Hot Shot, and they tried putting Hot Shot in, and Hot Shot lasted for a couple of months, and the compressors burn up. These systems are designed for a specific refrigerant. You need to know with R22 and R410A the different types of oils. PO oil, ester oil, there's multiple types out there. Oils are not compatible. An R22 system and a 410 system uses two different types of oil. If you take and when my guys go out and work, they have two sets of gauges. They got an R22 gauge, they got 410 gauges. Don't put an R22 set of gauges on a 410 system if you've been using them on 22 and you go out and you want to add refrigerant to a 410 system and you run them through a 22 system gauge, you're putting 22 refrigerant in that system. There's some refrigerant left in that gauge, but more you're putting the oil that's in that gauge in that system too. And the two oils will create an acid, wipe the compressor out, gum it up, just destroy it. So make sure that you look at whatever piece of equipment you're working on, make sure what the oil is in it, because there's multiple types of oils out there that are not compatible with each other. PO oil, POE oil, it's what's used in 410 systems. That stuff is like a sponge to water, moisture in the air. If you have an open container of PO oil setting open for 20 minutes, it's a milky color. The moisture just sucks into that oil and turns it a milky cloudy color. So you got to really be careful with 410 equipment that you're not leaving it open for any long period of time. If you're changing a compressor out, wait till the last minute to pop the plugs off the compressor, hook your pipes up to it and braze them in. Don't pop the plugs off and work on a whole bunch of stuff here and work your